All right. In an enthalpy problem, you will typically be given not bad, a reaction. So I'm just going to make one up. It's just like A plus B goes to AB, and then on the right it will say delta H is equal to like negative 25 kilojoules. Okay? For the rest of the year, typically if you're given a reaction, it will give you the enthalpy of that reaction just with it. Okay? Enthalpy of the reaction. Now, the enthalpy is an extensive property, which it means it does depend on how much of the stuff you have. All right? Which means it will depend on if there are coefficients. So if it was like 2, 1, and 2, you would definitely use the coefficients in the picket fence when we do these problems. Now look right here. This says 25 kilojoules. What that means, it says negative, sorry. That means it would be negative 25 kilojoules for every, that's supposed to be J, 2 moles of A. Tell your lab partner where the 2 came from. Right here, right? It means it's negative 25 kilojoules per every 1 mole of B. And how many for AB? 2. Now, it could, it's not balanced. I was just making up coefficients. You could be asked to solve for any of them independently. Typically, it will just be for the formation of the product, but whatever. Now, if you have this given to you, but then they ask a problem, so let's say this was a solid. And it said, for the precipitation of AB, you get this. But then there is a math problem that certainly could say, if AB were to break apart, yada, 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 and it could ask you another question. But that would be the other direction, correct? So look, the enthalpy for the reverse reaction from your reading is the same, but what? No. From your reading that no one read, even though it was in italics. It's in italics. It says, for the reverse reaction, it's equal but opposite in sign. So if A plus B goes to AB, makes negative 25, that means it's exo, right? If you go this direction, it requires 25, or endo, so be positive 25 kilojoules. So the enthalpy for the forward and the reverse are the same, just different signs. Okay, now, let's just attack these problems. They're not super hard. Here we go. It says, how many joules of heat will be released when 50 grams of react with chlorine to form AgCl? Now, you need more. I had it written, and when I cleared all, it just you need to know Ag plus Cl minus goes to AgCl solid. And then I'll make this number up. Delta H, we'll just say it's equal to negative 70 kilojoules. So the first thing you would do is check if it's balanced. Is it balanced? Yeah, they're just ones. They're not written, but it is balanced. Okay. So now I'm just going to do a picket fence. Picket fences will apply to chapter 2, 3, 4, 5, 10, 14, 15, 16, 17, 19, and 21. Those are the chapters that we're going to use picket fences. Most of the class will use a picket fence. So I hope that they're okay. You take your given, which is right there, right? Yes, ma'am. Yeah, you will do a ton of conversions. Now, you're going to eventually... All right, so the thing that you're given is what you always start with, which I gave you 50 grams of Ag. Now, we've done this 100 times. What unit must come down here? What about Ag? The grams of Ag. And grams is always tied to what thing? 1 mole of the same thing. Now we just find that on the periodic table, and it's 108. Rounding. All right, then, what am I solving for here? Joules. All right? So now, I need to get rid of moles, don't I? Okay, if you remember, I just told you this is per mole. It relates to the coefficient. So for every 1 Ag mole, how many kilojoules do I have? Negative 70 kilojoules. That's a J, supposedly. Just as 1,000, or like a gram and a kilogram. So 70,000. Move it 3 places. Okay, now I'm going to do it inside the picket fence, but you don't have to. Oh, that's the line tool, I remember. So this step, if it confuses you, just don't worry about it. But for every 1 kilojoule, how many joules do you have? And then you're ready to roll. So what Brinley did, she just started that. She just converted that to 70,000 and called it good. That's fine. You can do it in the picket fence. You can do it in the answer. You can do it in the steps, whatever. It doesn't matter. So then you just multiply. You will need a calculator today. So if you need one, you can use your phones or have some loaners. All right? So all we've really done is taken something we really have already been knowing how to do. We've just added this factor. The kilojoules. Yes. That will be given to you. It's written. It will be on the right side of the equation. I'll show you real quick. We'll do one of these in a second in the book. So it'll give you the problem, and then this part's always just hanging out. That will be a given. Okay. Are we good so far? Okay, so please don't overthink this. Like I had a kid first hour, I turned the page and she's like, I'm like, no, you picked that pencil up. This is not bad. We've done way worse. All right? We can do this. All right. Here we go. This is not looking pretty. Can I move this now? Oh yeah, I forget that every time. I'll just rewrite it. So, we just did a simple, I just made it up. Magnesium reacts with who gives a crap in a 1-to-1 whatever. You with me so far? And its delta H was equal to a positive 88 kilojoules. You okay with that? All right, how many joules, sorry, we'll go kilojoules just to save time. If 200 grams mg react. Try to do that. We'll give you till this says 1010. So what's the given? 200 grams. I'm trying to find kilojoules, right? Of mg. No, whatever. Yeah, I guess it is just mg. Yeah, it said how many kilojoules. I tried to make it so you didn't do the conversion, and that made it, maybe that made it worse. So 24.3 grams per 1 mole, right? If you didn't put the 0.3, I still think you're a good person. You can if they feel like it. All right. You're going to see one in a minute. Don't you drop your pencil. All right, what did we end up with? 741, is that this one? 733? Okay. So not that bad, right? Thank you. Here we go. You ready? Thank you for being ready, Diane. We're going to switch it up because we always do.
Is this the hard thing to do this unit?
No. Hold on. Oh, where did it go? Did I delete it? Oh, crap. Where'd it go? Here we go. Shh. Stick with me. Now, I'm just making up A. It has a molar mass of like 55 grams per 1 mole. You okay with that? Grams of A to produce 700 kilojoules of energy when A plus B goes to AB. Now, we'll add a teeny bit more. We'll say it's a 2, 1, 2 if we balanced it. And then it's missing one piece of information, right? If delta H is equal to 54.5 kilojoules. So this steps it up a little. It's still just a picket fence, though. If you can find the way to diagram it and put it together, it won't be that bad. Okay, please remember, the key to the picket fence, please stick with me. The keys to the picket fence is to find the thing to start with. The thing you start with typically is the loner. This 700 kilojoules, it's not tied to anything. Now, I know that this looks like it's a lone, but remember, it's per whatever the coefficient is for the thing, right? So I'm going to start with my 700 kilojoules. And what do I want to solve for? Grams. So I'm going to come over here and I'm going to follow the same process we've been going through. How do I get rid of kilojoules? I have to put it down there. So it is this now, correct? 54.5 kilojoules, and that's per every what? 2 moles this time. Because we're talking about A, and A has what in front of it? That's right, but we have never, when we've done our molar mass, we've never doubled it ever. That 2 is there. It's right here, though. But whenever we found the molar mass, we've never applied the coefficient to it. So that's a good question, but the reason why is it is accounted for. It's just accounted for in this step. So this is A. So now, for every 1 mole of A, what do we say its molar mass was? 55. So, Brinley, one more time. If you look, the 2 times 55 is here. It's just, if you do it here, very often you'll do it twice on accident. All right, and so this was grams. And so, wow, this was dumb. It almost is just 700, right? It better be. Oh, there's a 2. You're right. I'm sorry. So it's around 1,400. 1412? That's good enough for me. That was a good year. Yeah. Hey, what number would be like, this would be 11 if we were going, and this would be a 13, right? What's important about 11, 13? It's my birthday, freaks. Do not forget it. That's 6 days from today. I like Mountain Dew and chocolate. That's all I'm asking for. Tuna fish is sort of okay. Here we go. So this is the same chemistry we did before. Before I made the enthalpy up, so that's why it's different. This is the real enthalpy. So A, calculate it for 0.2 moles. So it's already in moles. You don't have to use grams. So A will only have 1 single vertical line. But B will have 2. All right. Letter C will have 1 because it's in mole. But C is really weird, correct? What's weird about this right here? You've never seen it before. Millimole. It's a type error, right? It means a millimole. So it really means 0.00015 mole. It is. Okay. Now, I'm going to give you 4 minutes to do these problems. Ready? Set. Go. Okay, so please look at A with me. A, you're finding delta H, which is kilojoules, for the formation of 0.2 mole AgCl. And this gives it to you. For every 1 mole AgCl, you have 65.5. So you just multiply them. 13.1, is that what I remember? Okay, thank you. This was a negative. Negative 13.1 kilojoules. Who had that? Who's okay with that? All right, good. Letter C. Letters, whatever, B. Yep, that's after A. Okay. Now, it's in grams, so we just have to start with that and do one extra step. 2.5 grams AgCl. What's the mass? 143, sorry. 0.5? It doesn't really matter. It won't matter. And then it's the same thing at the end, right? 1 mole AgCl for every negative 65.5 kilojoules. I'm sorry. It doesn't get that much harder, I promise. And then, so everything cancels out except for kilojoules, and what do we end up with? Negative 1.14? What don't you like? Post? I thought you said, wait, why doesn't it? Okay, now, please, if you would, pay really, really close attention to part C, because it's tricky, and it's not because it's millimoles, it's tricky because of chemistry. When delta H, when I almost said dissociates, whatever, dissolves in water, this, as written, it's forming a precipitate, right? But this is asking you if the precipitate were to break apart. So it's the reverse reaction, which means when you reverse a reaction, what do you do to the enthalpy?
Multiply it by -1.
Okay. You switch its sign. Because if it gave off 65 when it was formed, it's going to take 65 to break it apart. We okay with that? Okay, so just remember, for part C, we now have a endothermic process. Already in moles, so I just need 1 picket fence, right? So it is 0.00015 moles, and I got that because it's millimoles divided by 1,000, or the decimals 3 places. All right. For every 1 mole, I have now positive 65.5 kilojoules, and I just multiply. All right, how do we feel about that? What's that? Test tomorrow? Well, how about